Okay, so lesson 3.3 should be article number 7 in your index. In lab sheet 3.3 should be article number 8. Hopefully you've already done that. I need everyone to have 3.3 in front of them as I review the expectations for today. So today we're looking at squaring a circle to find its area. This is really cool. This is another proof to how 3.1 pi exists. Okay, it's another way other than just showing you circumference divided by diameter. We know that that's one way that pi exists. This is another way to show you how pi exists. So, squaring a circle. We have up here basically 5 different areas that we're going to fill in for this chart. On your lab sheet, you have 4. And I'll explain which one that I added on here that you don't have on your lab sheet. There is a term that we'll be using a lot of. It's called radius square. It is literally the radius of a circle turned into a square. So this is a radius square. This is a 3 by 3 radius square. So radius of the circle is 3. I would fill that in, and you should do the same right now as well. The area of the radius square. So here's the radius square. Okay, it is 9. How do I know? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 different boxes in there. Number of squares outside of the circle. So this is where I have to look at, okay, I've got my radius square. What about the boxes outside? Well, I've got 1 here. And it looks like if I took those and these little pieces, it might make 2. So I'm just going to put close to 2. So it's basically 2 squares are outside of the radius circle. So I'm going to put a 2 on the outside here to represent the number of squares outside. So how many squares on the inside? If there's 2 on the outside, there's 7 on the inside because it equals 9. So, okay, so now Lane's already doing the math. She's like, well, if I know that this radius square, and there's 4 of them, okay, she's like, well, then that means there's 7 here, and 7 here. So the area of the circle would be 28.
Are you sure there's 7 in the...
Okay. Well, these are estimates, right? They're estimates. These are not exact. We're not using the formula to find the area right now. I'm showing you proof that pi exists. So now, we know that the area of 1 radius square is 9. Correct? And we have 4 radius squares that would partially or fully cover our circle. But out of that fully cover, there are sections that are outside of the circle. So the area in the circle is 28 radius squares. So if you have 28 squares, how many radius squares would cover the circle? Talk to your partner. How many radius squares? Not 4. No, because look, I had this is all outside.
I don't understand. Pi. It's pi.
It is pi. Now, so, yes. You get it? So look, hold on. Sarah, hold on. Because 9, there are 9 squares in a radius square. Right? We're good, right? But there's only 28 cover the whole thing. So what's What's pi times 9? It's almost 28.
I got 3 points.
This is the second proof that shows you that pi exists. And it's using what they call a radius square to show you that it truly does exist. Outside of just circumference divided by diameter. Do you see it now, Sarah? You see how we said there's 28 squares in here, right?
Right.
One radius square, which is this, is 9. So how many of those that are fully like this would fit in there? 3.14. 26. So it's pretty cool. So the number of radius squares needed, you could write 3. 3 would be a good answer because 3 radius squares would give me 27, and that's pretty darn close. Right? I'm one off here. So what is a radius square? It's the radius of a circle squared. Hold on. Squared and positioned. I need you to write down your definition here, Lane. What is a radius square? It is the radius of a circle squared and positioned from the midpoint to 1/4 of the circle, because there's 4 quarters in a circle.
Wait, did you say that? Oh my God.
It's the radius squared. Okay? And positioned in 1/4 of the circle. And part of it is, part of the radius square covers a quarter of the circle, and a part of that radius square is extra. Okay? It goes beyond the circle. So this last question, no. But this last question I want you to talk to your partner about. What mathematical operation would I use to find the number of radius squares needed? So you need to look at our data, and I want you to talk. What's the mathematical operation I would need?
Multiplication.
Why multiplication? Why?
I don't know. We don't have that one on our paper. 25.
Cody, why? Why multiplication?
Because you need to multiply by quite a bit.
Okay. Do you guys see what you do to find it? It's basically your radius times your area of your radius square. Do you guys see that? It's this times that will pretty much equal this. Does that make sense? When I multiply my radius by my area of my square, it's going to... Here, wait, is that true? No, it's not true. That's not true. No. It works here, but it will not work on others.
Well, the area of the circle is 28, not 27.
Okay. I want you to go ahead.